welcome to True Projects. In this video, we are going to explain about the project, which is application of a deep learning technique to nonlinear images from human tissue biopsies for shedding light on breast cancer diagnosis. Breast cancer is among the most common cancer types in women worldwide and ranks second as a cause of cancer death. Breast cancer is caused by a combination of genetic and environmental factors while displaying different phenotypes according to pathophysiology of each patient. However, the routine histopathology is time-consuming and involves tissue fixation, slicing, staining, and finally microscopic examination by experienced pathologists to reach a diagnosis. So this project addresses that there is a growing need for the development of new, rapid, label-free, non-destructive imaging-based diagnostic tools to objectively evaluate morphological features with subcellular resolution and molecular compositions that are closely associated with malignancy. In response to the urgent need for the faster breast cancer diagnosis, this project combines advanced image and deep learning techniques to create a rapid, accurate, and user-friendly diagnostic tool bypassing the limitations of traditionally histopathology. The primary objective is to develop a streamlined and efficient breast cancer diagnosis system. We aim to utilize convolutional neural networks for image analysis and aim to employ the mobile net architecture for enhanced processing. These algorithms are used to facilitate rapid and accurate breast cancer diagnosis, enable automated analysis, reducing dependency on time-consuming histopathology, enhance the ability to distinguish between benign and malignant tissue. Ultimately, goal is to improve early detection and treatment of breast cancer, ultimately reducing mortality rates and enhancing healthcare accessibility for women globally. For implementing the project, we need hardware and software requirements. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software requirements, we need Anaconda 3 and Visual Studio Community version. In the flow of work, we have designed few modules to implement the project. The first one is importing the packages. This module involves importing the necessary software libraries and tools for the project, and they are NumPy for numerical operations, Pandas for data manipulation, TensorFlow for deep learning, Matplotlib and Seaborn for visualization. Exploring the dataset. In this step, the dataset containing breast cancer grade tissue data is loaded and examined for initial insights. Image processing. Within this module, the image data generator is utilized for several data augmentation techniques including reshaping the image. This step involves adjusting the image size to a standard scale. Rescaling ensures that all images have consistent dimensions, making them suitable for input to machine learning models and reducing computational complexity. Shear transformation. Shear transformation distorts the image by slanting it in a specific direction. The purpose of this is to introduce variations in the dataset, improving the model's ability to recognize tissue patterns based on different angles or orientations. Zooming the image. Zooming changes the image magnification level. It provides different views of the tissue, helping the model detect features at various scales and enhancing its overall robustness. Horizontal flip. This transformation flips the image horizontally. Horizontal flip creates mirror image versions of the tissue, diversifying the dataset and reducing model bias towards a particular orientation. Reshaping the image. Reshaping adjusts the image dimensions as aspect ratio. Reshaping ensures that images have a consistent format required for input into the machine learning models, making them compatible of further processing. Data extraction into train and test sets. This step involves partitioning the dataset into separate training and testing subsets to facilitate model training and evaluation. Model building. In this module, two distinct approaches are employed. The first one is CNN, which is convolutional neural network, a deep learning architecture that is designed for image analysis. It is used in this project for its ability to automatically learn intricate features from the breast tissue images, aiding in accurate classification. MobileNet. It is a lightweight deep learning architecture optimized for mobile and embedded devices. This is used in the project for efficient image processing, enhancing the speed and accessibility of breast cancer diagnosis. Ensemble method with the combination of MobileNet and CNN. It is a combination of MobileNet and CNN models for improved predictive accuracy. It is used in this project to leverage the strength of the both models, achieving a more robust and reliable breast cancer classification system. Training the model with the train and test dataset. The models are trained using the designated training dataset and evaluated against the test dataset to assess their performance. Flask framework with SQLite for sign up and sign in. In this step, the Flask web framework is set up with the SQLite database integration for user registration and authentication. User gives input. Users provide their input through the web interface. The given input is pre-processed. The user provided image is converted to an array format. The image is reshaped and required for input to machine learning models. This will be done by using Keras image to array and reshaping the image. Train model is used for prediction. The pre-processed input is passed through the trained machine learning models to make predictions about the breast tissue status. Final outcome is displayed through front end. The prediction results are presented to the user through the web interface, allowing them to access the diagnosis and relevant information. For execution of the project, we need to open the code folder of the project which contains the source code files. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And this is the notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells. This is the signup.db file. This file is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So we will copy this and open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path. This command is used to change the current directory to the code folder's path. Now we will click on enter. So by using this command, the current directory is changed to the code folder's path. Here we need to type python space app.py. This command will compile the app.py file. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost and the port number, unless configured differently. So this is the localhost and this is the port number. Now we need to copy this local link provided by the Flask framework and paste it in any web browser. I will paste it in Google Chrome. So here we will paste the link and then click on enter. The homepage of the project is displayed in the web browser, which is built by using the Flask framework. Now we need to click on login. So here we will enter the username and the password. Now we will click on login. So we are redirected to the homepage of the project where we need to upload the disease file, disease image. For that we will have the predictions whether the image belongs to grade A, grade 0, grade 1, grade 2. Now we will upload the image. So we'll select this image and click on open. Now we will click on upload. So for this particular uploaded image, it is predicted that the given input cancer type is grade 0, which means it belongs to the grade 0 cancer type. Now we will upload another image. So now we'll upload this image and click on open. And now we'll click on upload. So for this particular image, it is predicted that this cancer type belongs to grade 1, which means it is at stage 1. Now we will upload another image. So we'll upload this image and click on open. And now we'll click on upload. So for this uploaded image, the disease is detected here. And for this particular image, it is predicted that the cancer type is grade 2. Now we will try with the other image. We'll upload this image and then click on open. Now we will click on upload. So for this particular image, it is predicted that the cancer type is grade 3, which means it is at stage 3. In this way, we can upload the chest X-ray images. For that, we will have the predictions, which are grade 0, grade 1, grade 2 or grade 3. Now we will sign out. By combining advanced image processing techniques with deep learning models like CNN and MobileNet, this project has demonstrated a more efficient and accurate method for breast cancer diagnosis. The integration of Flask for the web interface and SQLite for the user registration enhances the accessibility and user-friendliness provided by healthcare professionals and patients with a straightforward and effective diagnostic tool. It showcases the ensemble method that, combining with MobileNet and CNN model, showcases the potential of leveraging multiple algorithms to achieve better prediction accuracy, addressing the complexity and heterogeneity of the breast cancer tissue. So this project ultimately enhances that global healthcare accessibility, contributing to the fight against breast cancer and its impacts on women's health.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.